Hey everybody, I got a quick one for you. This time, this video is on finding inverses from graphs and tables. And this should be relatively quick, but I want to start off with sort of a theory idea. So the idea that I want to get across here is that the way you find inverses is to switch x and y. And let me draw a picture to illustrate why that is, and then we will kind of show you how to do it on graphs and tables until like the last couple minutes of the video, because it's not that complicated. So here's the idea. We've got our x's and our y's here. And our x's are going to be red. Sure, they'll be red. All right, everything in here is some x, and everything in here, some blue y. And if you have a function, f of x, that takes one of these x's and turns it into a y, right, that one right there, and or you have some function f inverse that takes the same point and brings it back to where you started from. So this is f inverse, and this guy is f. The thing I want you to see here is that the roles of x and y are reversed in these two functions. F takes x's, starts with an x, and takes it over to a y. F inverse starts with the y and takes it back to x. So if I write it like this, that if f of a equals b, then f inverse of b equals a, then the thing I want you to notice here is that what we're really doing is we're switching the x and the y, right? So this guy is x, and this guy's x here, and this guy's y here. And so in the inverse, we're putting in, that says a, we're putting in the outputs and getting out the inputs from the original f. So what you're really doing is you're switching the roles of x and y. In f, the x's are the inputs and the y's are the outputs, and in f inverse, the y's are the inputs and the x's are the outputs. And what that looks like in a table or graph is actually really simple. So for instance, let's do tables first. Tables are easy. They're probably the easiest ones. And we'll see what it looks like on a graph. So in a table, so let's say I have x and then f of x. And I'm not going to specify what f and f inverse are here, because we don't need to actually. So let's say x is my standard 0, 1, 2. The standard x's, and the f's are something 1, 7, negative 13, 8, and negative 5. Then if I want to make a table for f inverse, the thing that I know about the inverse is that when I put in the outputs from f, I get back the inputs that they came from, right? That's what inverses do. So if these are my inputs and I put them into the inverse, well, I don't necessarily have a general table for f inverse, but I do know, so this says that if I put 2 into f, or if I put negative 2 into f, I get out 1. So that means if I take 1 and put it into f inverse, I should get out negative 2. Similarly for all the other ones. Second row here says if I put negative 1 into f, I get out 7. Well, if I put 7 into f inverse, I should get out negative 1. So you can see what happens here. And it's really simple. You literally just flip the table over, right? That's how you find the inverse. That's how you find a table of values for your inverse function. We're going to use this when we get to logarithms and exponentials. This turns out to be pretty important. Luckily, this is one of those things that's both easy and also important. So great. So let's see what this looks like on a graph. This is a little more interesting. Yeah, so let's do this. So let's say I have this table of values for f, right? And we're going to graph them. I'm going to pick a more reasonable table of values here. So let's say -2, -1, 0, 1, 2. So let's say I've got -4, -1, 0, 1, 4. All right. So let's say that that's my table. Okay. Let's look at what this looks like when I graph it, and then we'll see what happens with the inverse. So I'll see if I can do a nice job of trying to do a nice clean graph here. Hey, when I go slow, it comes out not too bad. Okay. So -2, -4, -1, -1, 0, 0, 1, 1, and 2, 4. 4. All right. So I've got those on there. So now I'm going to do this in blue just to highlight the difference. So if I have these inputs, maybe I should have made these a little bit different, but that's okay. Actually, I do want to make these different. I'm sorry. I don't like what I've done with this with these points. I'm gonna back up for 1 second here and make this make those 2s just so it looks a little bit different. Otherwise, you'll see why I wanted to do that in just a second. But I don't like where this is going. 2, 2, and then I can erase these guys. Here and here. Okay. So for the inverses, I'm just going to flip the table over, right? So -4, -2, 0, 2, 4. We got -2, -1, 0, 1, 2. Okay. So when I graph these, now I've got -4, -2, -2, -1, 0, 0, 2, 1, and 4, 2. And I want to draw some lines here to show what went where. So this went to here. This went to there. This stayed the same. This went there, and this went there. Right, and it kind of looks like I rotated things, which actually isn't quite what happened. What actually happened is this. Some contrasting. There we go. This is the line y equals x. Right, slope of 1 and y-intercept of 0. What's happening when you switch from a function to its inverse? This is the function 2x, by the way, in case that wasn't clear. What's happening when you switch from a function to its inverse is you're reflecting through the line y equals x. And the reason you're reflecting through the line y equals x is that you're switching all the x's and y's. So what you're doing is you're turning y into x and vice versa, and x into y. And so the thing that you get is a reflection through that line. Y equals x becomes essentially a mirror. Any point over here ends up over there. Any point over here ends up over there. You're just reflecting across that line. And I'll show you why this is useful with a better picture or with a different picture. But that's actually what's happening here. So let's do a different one. So let's say I have this function. So here's just a random, not random graph, but let's say I have a function that looks like this. I think you'll agree with me that that is a function, passes the vertical line test. what if I graph the line y equals x? And it does this. All right, there's my line y equals x. Could I figure out what the inverse of this function looks like? And I can just by doing a reflection. Right? And so you might say to yourself, wow, that looks kind of hard to reflect. And I agree. So here's some tips for you. Wherever it crosses, wherever f crosses the line y equals x, those points don't go anywhere. This point right here and this point right here are going to stay right on the line, because when you reflect through the line, but you're already on the line, you're not going anywhere. And then what I like to do is I like to just pick a couple points, sort of anchor points, if you will. So like this looks like a good point here. So if this is on f, then the corresponding point would be over here on f inverse. So what you can do is you can just go perpendicular to the line y equals x, same distance on either side. Right, you just sort of cross the line. You can also think of it as switching x and y, right? So that's really what I did here. I said to myself, well, this is the x-intercept of f, and so the y-intercept should be about the same distance up the y-axis, right? And similarly for some other things, I would notice that f here appears to be going towards the negative y-axis, so f inverse should be going towards the negative x-axis, right? So I should have something that, like, you can see this goes kind of smoothly up through this point here, up until it hits this point right here. Okay, well, that's what I'm going to do over here. I'm going to go sort of smoothly to the right through that point right there until it hits right here. Anywhere it crosses, like, so you can see this area kind of crosses over y equals x, well, I'm going to cross under in the same fashion, right? So stay close to the line and go like this. Okay, so this, here I want to erase a little bit of this stuff. I want to erase that and that. Now you might notice that this function is not one-to-one, right? F is not one-to-one, so its inverse will not be a function. And so you can see how it goes up here and then down. Well, up is increasing y. That means that that goes with increasing x in the inverse, right? So this goes up and then down. So this is going to go right and then left, because increasing x is to the right, increasing y is up. So basically up translates into right. Similarly, down translates into left. So that means we're going to have something that looks like, let's see, so it like peaks right here and comes down and sort of heads towards the positive x-axis, so it should head towards the positive y-axis. So we're going to come left. Oh, that's absolutely terrible. Let's try that again. All right, so it peaks here and then kind of comes down like that, right? So what I like to do, this is not the greatest drawing I've ever done, but I hope it's relatively clear here. So the thing I want to point out here is this. Pick a couple points, switch the x's and y's, and just plot them on the other side to give yourself some anchor points to draw between. Increasing y is up. Increasing x is right. So when you switch x and y, something going up translates into something going right. Decreasing x is, or decreasing y is down, so that decreasing x is left. So something going down here, this down slope is a left slope over here. And you can see that if I reflected the black line around this line y equals x, I would get the blue line. Well, I would if I could draw. I would get the blue line if it was well drawn. I hope that's reasonably clear. And that's what it looks like. That's what inverses look like on a graph. They're just a reflection through the line y equals x. And the reason they're a reflection through the line y equals x is that the process of finding the inverse of a function is literally just switching the inputs with the outputs, because the inputs into f are the outputs, or the inputs into f give you the outputs that then become the inputs into f inverse, that bring you right back to where you started. So the X's and Y's just switch. That's really what you're doing, like mechanically. And this is the way it shows up on a graph. You get this reflection through the line y equals x. And that's really what I wanted to show you about graphs, inverses on graphs and tables. That's kind of all I wanted to say there. So I'll go ahead and stop the video, and I will see you guys in the next one.